Will time slow down? There is such a plot in science fiction movies. A man travels to space in a spaceship. A few years later, I return to Earth only to find that hundreds of years have passed. It sounds ridiculous, but it's an inference based on a scientific theory. Special relativity tells us that for observers of relative motion, time has passed. In other words, clocks in motion slow down. This leads to the phenomenon of the twin paradox. We usually think of two clocks as identical. The movement of the watch hand is the same at all times. The time shown should also be the same. But in fact, the following experiment will tell you even the same clocks and watches are different in their own state of motion. The time displayed will also be different. Before the experiment begins, you need to hang a box with a mirror hanging from the ceiling first. At the same time, place a light source on the floor. This way, when the light is shining upwards from the light source, it will reflect back to the floor from the ceiling mirror. Here the clock will shoot light out of the floor and the time to return to the floor is set at 1 unit of time. We know when the box is stationary. If you divide the height of the mirror from the ground by the speed of light, the time it takes for light to reach the ceiling from the floor can be determined. Multiply the result by 2 to get the time it takes for light to make a round trip. So, let's say now let the box start with a certain speed does a uniform linear motion. How would the person in the box feel? Will he still see it? The light first moves vertically upwards from the floor. When it reaches the ceiling, it moves vertically downwards after being reflected, and then to the floor. And it's the same process of light reflection. What about the people in the room? In fact, when the box is in motion, the light emitted by the floor, it looks like it will rise obliquely with the movement of the box itself. It is reflected by a mirror in the ceiling and then descends obliquely to the floor. So it's compared to what the people in the box see. The person outside the box saw the scene. The light seems to have traveled a longer distance. That is to say, the light travels the distance of the box. It is obtained by dividing the distance he sees the light travels by the speed of light. The value is undoubtedly larger. From this we know the round-trip time of the light measured by the people in the room, longer than the person in the box measured. This shows that a clock in motion appears to a person who is stationary. It will be 1 unit longer than your own clock. That is, the clock in motion will slow down. Based on the above conclusions, let's take a look at the twin paradox. A pair of twins born at the same time as a stay on Earth. B travels into space with a spaceship. Suppose that the speed of the spaceship B is 80% of the speed of light. It takes him 5 years to get to the target star, and 10 years to go back and forth. So when he finally returned to Earth, A would be 10 years old. And what about B? Since he travels at nearly the speed of light, so he only spent 6 years on the spaceship, which is 6 years old. Of course, if B is traveling on a spacecraft that is 99% of the speed of light, then it may only take him 1 year to travel back and forth to Earth. Why is B younger? There is no doubt that the clock in motion slows down. Take the Earth where A is located as a reference. B is moving at high speed, so the clock that measures his time will slow down. He's going to age slowly, but then a problem arises. The motion of the spaceship relative to the Earth is also moving relative to the spacecraft. In this way, B is used as a reference. The Earth where A is located is in motion. From this, according to the theory that a moving clock slows down, the A's on Earth should age more slowly. Which of these two conclusions is true? Is the theory of relativity wrong?